1 2 1 2. What's going on? Okay, so if you're watching this video back after the live has already finished, this is probably going to be a really fun one. Just for the initial first probably 5-10 minutes of this stream, we're just going to be setting up and waiting for my live audience to appear. So feel free to jump and skip ahead to where the main content starts. We've got Sinewave02 in the house, and yeah, this could be interesting. So what's going on, guys? Welcome to a cheeky little Wednesday evening stream. Hello, Lowry. Hello, Lustinian. Hello, Joseph. How's it going, man? Boom, boom, boom. Oh, Joe. Yeah, this is your Bassface 5K, hey? This is the one that you left here. We put the higher voltage transformers in. Evening. Okay, right, let's just check my cameras. We have overhead and scope is okay. Very good. Ah, it's mine. Yes, it is mine now. It is mine now, but this was the one that came from yourself. Hawaiian, I'm at work now. Oh, that sucks. Hello, RTS. What's going on, bro? What's going on, Mads? What's poppin', Adrian? Good to see you all here. Got the whole crew in the house. Mr. Sinewave, do you want to just speak a couple of words and we can make sure that
Yo. Can you hear this now?
I can hear you. I believe my stream can hear you as well.
Can you hear me tapping on this amp?
Nope, cannot hear you tapping on the amp.
Okay. Alright, let me try to fix that.
Big man from Uganda, what's going on? What's going on, Avak 4? It's very nice to see you as well. Trust me. Very, very nice to see you as well. Shove my camera over. So,
yes.
So, early birds in the stream, welcome to a cheeky Wednesday evening live stream. Now, we have Sinewave02, my good friend Sinewave02, who you may or may not know from TikTok and YouTube. If you don't, then go give him a follow, make some sick content. And we have my good friend Sinewave02 here because he is going to do something very interesting for us. You may or may not remember in a previous live stream a couple of weeks ago, maybe it was last week, can't remember, we modified a Bassface 5K 1 ohm stable amplifier, which is one of the new Chinese clones of the sound digital circuit full bridge thingy. We fitted some higher voltage transformers in that. We upgraded the rail caps and also the output FETs, and we changed the voltage regulation point and changed the protection circuit to account for the higher rail voltage. So this amplifier should probably make about 5K at 2 ohms, and possibly, who knows, over 8K at 1 ohm if it will survive. So that's what we're going to find out. I personally, myself, I don't have any big high current power supply, battery, lithium setup in the workshop here. It's just all kind of bench power supply stuff. So I don't have the ability to bench test that amplifier to its full power. But Mr. Sinewave02 here, my good friend, he does. So we are going to take full advantage of his ridiculously expensive battery setup and see whether this amplifier makes power or whether it just explodes.
Yeah, I'm rather worried.
You're a little bit worried. Yeah, I'm pretty worried as well. I think it's definitely going to explode.
I'll show everyone my disconnect. It's called this. The disconnect there.
Yeah, we got the screwdriver thing ready to go in case of power supply failure, because we've got lithium batteries hooked up, so essentially unlimited current available for when this goes down. So yes.
But yeah, before we run the test, I will need to obviously find some sort of clip point, or we can just do it in increments until we reach what we need to reach.
I think the first test that we need to do is we need to do the 2 ohm test, because that's kind of what I have gauged it to be like 5K 2 ohm amplifier now. So I think we need to do the 2 ohm test first,
Yeah.
personally.
All right.
Yeah, and
Cool.
then we go from there.
All right. Well, let me set up for 2M then. I'll go unplug some resistors. You're good at this. If I'm up 0.5 now and there's 8 resistors, how many do I need to unplug?
Well, if they're 4 ohm resistors, you just need two in parallel.
Yep. Bang on.
You
Come round.
because obviously they are, the resistors are only 1K rated, but that's continuous. Do you think that 2 of those resistors will deal with the dyno test in the 5 to 6K range?
What have I told you? Dyno tested the FP 14K on just one.
Oh, really? Jokes.
Yeah.
They'll be right then.
As long as I don't leave it running, it'll be fine.
Hi,
All right.
David. H1 Nicholas. Looks like a quasi-resonant switch power supply in that amp. Well, if you say so, my friend, I have no idea. I am not expert when it comes to switch mode power supplies in mains amplifiers. All I know is this one had some problems, and now I don't think it does, but I guess we'll see. What I've currently got on my bench isn't really the thing that, isn't the interesting thing for this stream. I'm just got this on the bench working on it, just while we kind of get started with this stream. But this is a Camco Vortex 6, if anyone's interested, with a switch mode power supply section fault, which I believe I've sorted. So I'm just fitting some IGBTs, and I probably won't power it up on this stream. I'm just going to do some soldering while we wait for the views to pick up a little bit. Hi Jefferson, what's up, bro? What's up, Scott? It's been quite a long while since I caught a live. Ah, yeah, wicked. Thank you very much for jumping on, my friend. Good to see you here. Glad you were able to make it.
Come on, give me 2M. Yeah. With lead resistance, that's 2M.
Spot on. So yes, we will do the 2 ohm first, and I don't know. I don't know what it's going to do. I didn't do any further upgrades to it. Like, I probably should have thickened up the board traces a bit. I probably should have swapped out the output inductors for the ones from the 13K, so that they're bigger. But I just wanted to see what can the stock parts take if we just increase the rail voltage. If it blows up, then it might be a good cool thing to do to send it back, and then I can do some different upgrades on it, and then see where we go from there. But yeah, hey yo, from NZ, from the much more reasonable hour of 9 a.m. Nice, that's crazy. So it's yeah, it's 8 p.m. here in the UK. 8 o'clock p.m. Love to see it. Nice little evening. Guy here says subscribed to Sinewave02. Nice. Anyone who isn't subscribed, go subscribe to Sinewave02 on YouTube and TikTok if you use either of those platforms. Highly recommended.
So, Sam, obviously looking at this amp here, the wire size I put in is literally what seems to be what
The
is meant
max
to.
little fit, yeah.
Yeah, so do you reckon that's going to be right?
Yeah, should be fine. I mean, your wire runs are very short, so it's not gonna...
I mean, the fact it's going to be at 2M should help it even more, to be honest.
Yeah, for sure. Okay, that's one IGBT that's going to fit in. Nice. Let's just do the next one. 4 p.m. here in Maryland. It was 3 a.m. the other night. Oh yeah, so that would be because I was streaming during the day here. That's how, unfortunately, time zones do be like that. Imagine if the whole world ran on one time zone. Actually, how would that change the world?
It probably wouldn't, because everyone will still have different times, like different lights of day and night.
If the
like
whole
dark,
world
bright.
was on one time zone, would that make things easier? Maybe. Why don't we see what DeepSeek has to say about it? Just out of interest, like I haven't used DeepSeek much, but people have been raving about it. Imagine, for instance, that the entire world ran on the same time. Oh, what's it called? Window, time zone. So everywhere in the world experience nighttime and daytime at the same time. Full stop. How do you think that would change the world we currently live in, comma, what would be the benefits and drawbacks of this, question mark? See what it says. Oh man, it's going ham. It's going ham. It's writing a freaking essay. Oh, it's still going. It is absolutely it is absolutely cooking.
I see your phone, yeah, and
Oh
crazy.
jeez.
Yeah, that's going ham.
It's going ham. I've piqued its interest. All right, we'll read that in a sec. Joseph says the world runs on the sun. It's impossible. Huh?
That's what I'm saying, bro. If you think about it, it'll be different. It'll be either nighttime or daytime,
Yep.
evening or dawn, dusk, what you call it. So like people normally sleep during the night, so I don't think time will really affect it. If you get what I mean.
Yeah, this is what, like, my initial thought is that actually I don't think it will really change much, in general, because it's not going to be like, oh, the night is the day and the day is night. It's not like, oh, nighttime never exists or daytime never exists. It's just that everyone's day and nighttime all over the world happens at the same time rather than at different times.
Yeah.
And I on the surface, I don't think in my head it will change it a great deal. Let's just see what
It wouldn't change it. It
DeepSeek
wouldn't
has to
change it.
say.
Because think about it. Before we had time or phones and that, everything was controlled by the sun.
Yep. Yeah, I just mean like in our modern world, are there things where it's convenient that in one country it's during the day, like so while one country sleeps, another country can be taking over of whatever online things or stock market things that need to be running. Do you know what I mean? I don't know if I'm explaining myself very well, but
No, I get you. I get you.
like if everyone in the world is sleeping at the same time, that might be a problem. Let's see what it says.
Nah, yeah. The whole world will come to a halt. I can't lie.
It would fundamentally alter how we live, work, and interact. Benefits: simplified global coordination, unified global markets, yeah, for sure. Improved communication, standardized schedules, cultural unity. A shared sense of time could foster a greater sense of global unity. Drawbacks: disrupted circadian rhythms. People's biological clocks would be misaligned with the natural day-night cycle. No. It hasn't quite understood my question. It said that in some regions, daytime might occur during what is naturally nighttime, leading to sleep disorders. No, it doesn't understand what I've asked. Challenges for agriculture and daily life. Farmers and outdoor workers would face difficulties as their work schedules might not align with natural daylight hours. No, it hasn't understood what I'm asking. I'm
Yeah,
obviously
it's
saying
still
that.
great for things like that.
No.
I've just lost the Allen key. That's no good. Here it is. I found it. Sam, I'm the worst, for losing Allen keys when I'm trying to do things like this.
Oh, still. What's up, Josh? How's it going, my friend? The most annoying thing about that would be the date transition would happen in the middle of the day. Why would it? Why would the date transition happen in the middle of the day? Why wouldn't it happen at midnight like it does? Is the Class D amplifier high oscillation with totem pole on the output MOSFET gate reliable? High oscillation with totem pole. I'm not sure what you're asking there. Like, are you asking just are Class D amplifiers in general reliable? They're much less reliable than Class AB, that's for sure, if that's what you're asking. Doesn't mean they can't be reliable, but in general, there are a lot more components in Class D, and there are a lot more delicate components, and everything has to be absolutely perfect in a Class D for it to work and be stable. And parts are stressed a bit harder in Class D running at idle. well, midnight clockwise would be in the middle of the day for those regions where the daylight cycle is misaligned. No, see this to you Michael, you have read this as the AI has read it. What I'm saying is I'm saying picture a completely fictional universe, a completely fictional planet, right? That is not even a circle, that's not even a planet. Oh no, okay, well yeah, let's just imagine, right, that all the countries in the world experience daytime and nighttime at the same time. I'm not saying, like, in the world that we currently exist, make everyone's clocks align. I'm not saying that. I'm saying that imagine a different world, a different universe, a parallel universe where all of the countries on the planet that we reside on have the day and night cycle at exactly the same time. Perhaps even just imagine that the whole world is just one country where the time is exactly the same and day and night happens at exactly the same time. That's what I'm saying. So imagine that day and night don't happen at different times in different countries. This obviously doesn't make sense and wouldn't be possible, but it's just a fun thought what's it called, experiment. The world would need to be flat. Well, yeah, something like that. Just some random universe that doesn't exist, that probably can't even exist. But it'd be interesting to think how would that change our existence if every single country had day and night time happen at the same time, rather than at different times. And obviously, by virtue of the fact that day and night would happen at the same time for every country, that would also mean that everyone's clocks would be the same. That's what I mean. Just me. Hey Sam, this isn't my Bassface, is it? No, this is Joseph Hammond's old Bassface, which was not technically repairable. So we modified it with some other parts I had laying around here and sent it to Donnell for a bench test.
Are you sure you're happy with 15.4?
Yeah.
I bet.
I just don't want 17.
I don't think you'll even turn on.
No, I don't think it will. I think it'll probably protect at 16.5 or something like that.
To be fair though, this amp was regulating at idling at 15 volt all the way from like 12.9 to like all the way up to like 15 is brilliant.
I think Larry said, I think nothing changes, only numbers on the clock, that's all. Yeah, so that was my initial thought as well. My initial thought is, well, nothing really would change. If anything, it would just be more convenient because people in different countries where the time zones are so different can communicate more effectively without having to wait, 8 hours for the country where they're trying to communicate with to go into daytime. Do you know what I mean? Yeah. Oh, fair. The Bassface does say it's 18 volt stable. What, the Team 5K? I mean, I guess you could try it, but I've set the regulation point so that the rail voltage won't increase past about, like, once you get above like 13.2, it doesn't equate to any more rail voltage. So we don't risk, there's no risk there really to there being crazy amounts of rail voltage or anything. Would be nice though. Bro. Then you guys could freeze like we do in Norway, because if it was just flat, the temperature would be the same also. Nah, see, in my thought experiment, the temperatures are different. Like, everything is exactly the same as it is in the current world, but just that everyone's day and night cycles are aligned. That's the only thing that changes. And obviously that can't exist in our universe that I'm aware of. But it's just a fun thought experiment really, to just imagine what would be different about our world if that was the case. I suppose it's like saying, what if the entire world just lived in one small landmass? Like if the world was only the UK or something, or if the world was only Germany or something like that. If there weren't other countries and the world was only a few million people large, and it was just we all resided in one country with one time zone. Hey Sam, I used a video that you made with using a bipolar to power up and work on half-bridge amps with the Quad IC drive card. Can you help with powering up the single IR2184 card boards? Well, it's the same process. All you got to do is just supply the amplifier board with all of its auxiliary voltages that that it takes from the switch mode power supply. So I'm pretty sure they're the same. I'm pretty sure it's a plus minus 15 and a 12 volts reference to negative rail, and then it should be fine. The thing with those boards though is I think that they are a lot more fussy with getting Class D switching initialized. So they might need a certain amount of rail voltage present to actually kickstart the Class D switching. You could kickstart it by injecting some audio signal. So if you are feeding it with all of its required supply voltages, auxiliary supply voltages, put a load across the speaker terminals, like an old speaker you've got laying around or something, or a dummy load, and then inject some RCA signal, like 40 hertz, and that should get Class D kick-started. If it doesn't, then yeah, that's annoying. But I haven't actually tried it on one of those boards. I don't really repair many of those. It's been a hot minute since I had one of those in. There's not many of them floating around the UK, and they are a very expensive repair when they do fail. So, from the United States, Louisiana, enjoying your platform. Oh, thank you very much, Georgia Johnson. Thank you very much. Appreciate you. It's great to have you here. We have people from all over the world in the stream this evening. Tell Donnell, the German, said hi, by the way.
Yo, yo, yo.
Okay, so let's just so the stream is up and running. We have 71 viewers. Okay, well, I'd say that's probably enough for us to get cracking on the main event of this evening, which is going to be bench testing the Bassface 5K Bare Vids modified. So, just for anyone who is new to this and didn't see that stream, what I have done is I had a Bassface Team 5K, which is just one of those generic Chinese sound digital clone. It's basically an SFB 5K. So imagine an SFB, Sundown SFB 5K or something that's the same PCB as that. Came in for repair with a shorted transformer. Now, I don't have any spare transformers for those. You can't really get them. So it would need to have a new PCB, which is kind of expensive. So the customer said, hey, don't worry about it. Just leave it and you can use it for parts. So I looked around and see what I had for parts just to see if I could do something fun with this. And I had in the loft, in the attic, I had a blown Sundown SFB 13.5K, which uses the same size transformers. Obviously, they're just wound differently for a higher rail voltage. And the Sundown SFB 13.5K uses 6 of these transformers, and the 5K uses 2. So I took some transformers from the SFB 13.5K and slapped them into the Bassface Team 5K. So obviously that only uses 2 of them. So we have the rail voltage potential of the SFB 13.5K, which is 200 volts of rail at its maximum. That's the maximum idling, freewheeling rail voltage that those transformers will create, fed with about 13.2 volts worth of battery input voltage. Now, obviously, because we have an increased rail voltage, even with just the 2 transformers, if we give that a 1 ohm load, that amplifier is going to try and make probably about 13, 14K. Now, obviously, the 5K board, it only has 2 transformers and it doesn't have the amount of MOSFETs and the output inductors to deal with that much power. So essentially, what this means is that if we upgrade the rail capacitors to higher voltage and the output FETs to higher voltage to take, to account for the higher rail voltage, which we've done, that amplifier, the 5K with a higher rail voltage, now should produce its 5K at 2 ohms instead of 1 ohm. So essentially what we've done is we've taken a 5K 1 ohm amplifier and increased the rail voltage, and so it should do the 5K or possibly more at 2 ohm. But we are of course curious to see what would it do at 1 ohm. I suspect catch fire, but that's what we're going to find out. So that is the premise of tonight's stream, and because I don't have any high current bench supplies or batteries setups or anything like that, I've sent the amplifier to my good friend Sinewave02, who, like I say, you should go and follow on TikTok and YouTube, make some great videos, and he is going to dyno it for me, which I'm very happy about because I don't like it when amps blow up. So the further away I can be from them, the better for me. So we have Mr. Sinewave02 right about here. We have a video feed directly from his workshop and his test bench here. So we've got the Bassface 5K on the bench. We've got a whole bunch of resistive loads there, as you can see. We've got the SMD AMM audio multimeter 1 and an oscilloscope and a clamp meter for the voltage. So we are going to start off at 2 ohms and just see whether it makes the 5K at 2 ohms or possibly more. And then go down to 1 ohm and see what happens. I almost guarantee you that the amplifier is going to fail. The output MOSFETs are probably going to go first. The power supplies are pretty strong. They're 1404s, so they're pretty stout. So I suspect that the output MOSFETs are going to blow first, and then whether the power supply effects catch fire as a result of the blown outputs, we will find out. Maybe we should do 4 ohm. Hey, let's do 4 ohm first, because that will be definitely safe. So that guarantees at least one safe bench test out of it.
All right, sweet. I'll
That's a
just
great
unplug
idea. Yeah,
one of them
unplug.
then.
So just leave one of your dummy loads connected, and we'll do a 4 ohm test to start with, and just see what it's doing at 4 ohm. Then we'll go down to 2, and then comes the spicy stuff with the 1 ohm.
All right. Let me just concentrate while I plug this in because I'm notorious for wiring amps backwards. So,
No worries. Have you done that before?
no,
Well, what have you wired amps backwards before?
one, but it still worked afterwards though.
Jokes. Did it like spark and smoke or anything, or?
No, the wires just started dancing around.
Oh, she. Yeah, I wired a Vibe Monobox 4 backwards years ago, and it blew the onboard fuses because it had onboard fuses, luckily. Yeah, it just killed the reverse polarity protection diode, but all the FETs were fine.
I'm gonna do it. I'm gonna put positive in first because that's that's the furthest away from me.
Just
All
me,
right.
2.5k at 4 ohm. I suspect it's going to do at least 3k at 4 ohm. That's my guessing.
You
Yeah,
reckon
be
it's gonna
not.
give me a bigger spark when I power it on because this thing struggled to start up on my bench power supply.
So it's going to draw a bit of current to start up. Yeah, it's not going to give you a spark, but it's going to draw a bit of current on power up. So what's everyone's guesses then? We need to get some guesses in the live chat. So based on what I have just told you about this amplifier and this experiment, I think what did I lock the rail voltage in at? I think I locked the rail voltage in at like 189 volts, okay? And obviously it's going to be some rail sag. But based on that, the rail voltage is freewheeling at 189 volts. And it's a full bridge amplifier. So what are we going to see at 4 ohm? Type your guesses now. Let's see. We've got a few guesses. We've got just me saying 2.5k. Fred Burt says 2.8k at 4 ohm. 2780 from Morten. 3200 at 4 from Scott. So most people are hovering around the sort of 3k mark. We've got some spicy guesses coming in. Canadian Bass with a 3750. My guess, I'd be leaning on like over 3.5k. I think it's going to be maybe like 3.6, 3.7k. Prolux Electronics thinks fireworks.
Oh, don't say that. I've seen enough of them.
I hope not, because that'd be really boring, wouldn't it, for it to blow on the 4 ohm test? That'd be
Bro, I
really
hope it don't blow up
annoying.
when I plug it in. All right.
Elliot with a 3600 watts. Nicholas with a 3.8k. Yes, yeah, I'm kind of the higher end of the 3k. That's going to be my guess, I think. Power Tone
Round.
Audio
All
with a
right. Do you guys
3k.
want to see the pop when I touch it on the terminal? See if
Oh
we
wait,
get a spark.
let me just go on. Yeah, we're gonna get a little pop when we a little spark when we touch the terminal.
I hope it's not a big one. All right. Let
If
me
it
just
doesn't,
confirm.
hang on. Morton says if it doesn't blow up on 1 ohm, you're gonna go down to 0.5. No, I don't
All
think
right.
so.
So this is
I don't know. We'll
ground.
see.
Ground cable. This is ground here. Let's make sure.
You're gonna need some more ISO on your camera there, my friend. I think, or you could leave it because the spark is bright, so you'll be able to see it. Yeah, leave it.
Right. Ready?
Yep.
Oh, it was a little one. Not
Yeah,
too
there's a little
bad.
one. There's not too much rail capacity. Sorry, there's not too many capacitors on the power supply side of these amps. So
Yeah, I was not too bad at all.
Michael says technically it might hit 4K. I think there might be a little bit too much rail sag for it to hit 4K, but I don't know. We'll see. Is that a LifePo 4 battery bank or LTO?
This is LTO.
LTO. Dr. Dyno put me down for 3750. All right, Frank with a 3312. Let's
I
see.
think yeah, this is the point where I have to put my trusty
So we're gonna put the impact gun in the
make sure it's the right
terminal,
way.
so that if the amplifier does fail and the power supply fails, then he can quickly undo and pull out the wire. Good shout.
Right, just remote now, and then we're good to go.
Yeah, sweet. So how are you going to calibrate the clip point, to do the test? You're just going to gradually ramp up. You're going to play the tone, then increase the gain, play the tone, increase the gain until you get to clipping.
It depends how long you guys want me to do it for. I'm more than happy to do it, let it cool down, and rerun the test until we find clip point that way.
Yeah. I mean, it shouldn't get too hot for him, but yeah. So we're
Right.
running it to just when the sine wave touches the rail voltage. That's hopefully what we're going to be doing. That's hopefully what sine wave's going to do. Where's my water?
Right, let me take this out because
Hold on.
that's Allen keys really touching the thing there.
Let me just grab my water. I'm a bit thirsty. I thought I brought it in here. One sec. All right, water has been acquired. That's just a little reminder for anyone watching. Make sure you stay hydrated. Go get yourself a drink. When was the last time you had some water?
Sam, where am I setting the gain on this?
The man's got that fucking big ass hydrated bottle. Well, I don't know, man. Obviously, I don't know what game position would be required for your setup. I mean, I'd probably just knock it to halfway and then
That's what I normally do. I normally go half.
Yeah.
Right.
Obviously,
Before
we're
we do
just
that,
going
then
to
let me.
clipping based on the head unit. Yeah, obviously, running the gain at a lower position will mean that each click on the head unit will equate to less of a jump in output. So I would maybe actually increase the gain to maybe like a third or just over a quarter. So that means that each click on the head unit will be less of a drastic jump.
Let me just set these settings. Subsonic down, low pass. So leave it. What should I put low pass? Leave it at 80.
Low pass, well, yeah, low pass. It doesn't really matter because you're playing just a single sine wave. So, I mean, we are going to play some music on this. So yeah, make the low pass filter be at minimum. I think we should play some music on this. Provided it survives the 4 ohm and 2 ohm tests, I think we should do a 1 ohm music test before we do a sine wave test.
This is confusing. It's weird on this one. The gain's like it's got 5 volt and 0.2 volt, but to me it's on the other side.
The markings, I wouldn't necessarily trust the markings to be correct. This is Bassface we're talking about.
Yeah, that's what I'm saying. So am I going all the way to the left, all the way to the right?
So ignore the markings. Obviously, to the left is minimum gain.
All right, cool. Yeah, because it was whacked all the way up.
Yeah, and then just go up maybe like a third or just under a third,
Yeah,
and just see. Yeah.
cool. Fine. Right.
15.4, yeah, so the batteries are currently idling at 15.4. I don't know what it's going to drop to. We'll see.
I'm just now setting up my overhead cam.
Can I just say, how sick is this setup? Is this streaming setup? We got me in the stream with like bare cameras here. Yeah, and then we got you in your place.
Yeah, it's pretty sick.
Zero latency. The audio quality is decent. The video quality is decent. Guys, this is pretty sweet, man. This is a great world we live in that we can do this and share this with you guys.
It'll be even sick if you guys can see this.
The clamp meter, yeah. I don't think we're gonna be able to see that, but that's fine.
No, you can't. All right, no worries. I'll keep an eye on it. Cool.
What's your overall opinion on Bassface subs and amps? It's mixed. They've released some absolute dog subs and amps in the past, and they've released some pretty good value for money subs. Don't know about amps. I've not really liked any of their amps. Some of their more recent amps, which this is one of, it's not a good amp per se, but in the UK, these sell for like 250, 260 pounds, which for a genuine 5,000 watts RMS is mind-numbingly cheap. So it's very difficult not to recommend them because they're so cheap for the power that they do make. Yeah, it's a tricky one really, but yeah, not a big fan of their amps. The recent subs that they've put out though, not bad. The Indie line, the Indie S series subs are absolutely fine. They're very similar to the old DD Redline subs. They're pretty good value for money, to be honest. Not bad at all. Don't mind them. But the older Bassface DB, was it the 12.2, the 12.1 and 12.2 were absolutely horrendous. They were rubbish. So yeah, it just does
Right,
depend.
we've got a sine wave on it for some reason. I think it's picking up. It says on it 16K. What's that? 164K? I think that might, but I don't know how it's a sine wave though.
Is the amp powered up?
Yep.
Yeah. So the oscilloscope will just be picking up the Class D remnants.
Yeah.
Yeah. So obviously that's auto ranged. So you're going to want to set a manual range for that.
Yeah, what I'm gonna do is I'm gonna play 40 hertz quietly, calibrate it to that, and then it should be okay.
Yeah.
I need to unplug one more resistor as well to get to 4.
Yep.
There we go. That should be 4M.
The collab we need more often. No, we can do it more often. It's just coming up with ideas of things to do. This was one of ideas that we obviously had, but yeah, just it's coming up with ideas of things that we can bring to you that Sinewave can do from his place and that I can do from my place that we can do at the same time. Does that make sense? It's quite difficult to come up with things that work, like this, remote collaborations and stuff, but. Yo,
Okay.
Willy Zilly, how's it going, my friend?
Right, let's get some signal into this. Sorry about the wait, guys. I'm just trying to.
No, that's cool. We're just chilling. We've got 110 concurrent viewers. So for anyone that's just joined, remember this was a Bassface 5K, which is basically a Sundown SFB 5K. And we've put transformers in it from a Sundown SFB 13.5K. So the rail voltage is much higher in this Bassface 5K. We've also changed the rail caps, we changed the output FETs to higher voltage, we modified the protection point, and also modified the regulation point. So the rail voltage in this 5K is now sitting at about 190 volts DC, and it's a full bridge amp. So I'm just very curious to see what this thing can do. What kind of power will it make with the much higher rail voltage in it, and see what kind of abuse it can take before it fails. That's the plan for this evening.
Right.
Soundstream LW 5.830, any good? I don't know that model, I'm afraid. Yeah, can't really comment. Haven't seen it, haven't repaired one, not had it on the bench. Voice chat bitrate is at 384 kilobits per second. Is that good? I have no idea. Jay thinks it's going to make 6.7k into 4 ohms. That is a far out guess compared to the other guesses that we've had. Rare. So yeah, we asked you guys what your guesses were. How much power is it going to make at 4 ohms to start with 190 volts rail voltage on a 4-bridge amp? It's going to have some rail sag though, so no point typing that into a calculator.
Well, it's working. Right now, I'm pulling 28 watts.
Okay, and it's playing the 40 hertz and it's showing it on the scope and everything, yeah?
I'm just going to get it to calibrate.
When are you putting GAN FETs in this? Very good question. I think they're going to require a different drive circuit to what these use, but it's definitely an experiment I want to do. I can't remember. I don't think I've seen any TO220 package GAN FETs that would be a nice easy drop in. All the sort of GAN FET stuff that I've seen is like a chip that has the driver and everything built into it. So it's like a fully integrated pair of GAN FETs plus drive IC plus bootstrap plus everything in one package that you then just give supply voltages, a filter network, and audio signal, and it just does the rest. And they're pretty expensive. So those would be fun to play with, but that would have to be like a project in its own right.
Right. Well, should we start doing some 40 hertz
Yes,
on
let's start doing some
4M?
40 hertz things.
All right. I
Yeah,
still got to calibrate the oscilloscope because I've maybe got to bring it up a division or so.
you definitely get. Yeah, I would go. Hang on a minute. Full bridge. I would go 20 volts per division. I would say on that.
Yeah, it's on 20
Yeah,
volts now.
yeah, that should be fine.
Okay.
Oh man, I'm bricking it. I think it's definitely going to blow up, but whether it blows up on 4M or not, I don't know.
Hey, stop doing this to me, Sam. Please have good thoughts. Because if it blows up, you're all right. I'm here. I have to. Do you know what I mean?
Yeah, you got to deal with it. I can just chill.
Yes. I hope I can just undo it in time so we can save it.
Oh yeah, we'll be like even if it cooks, like you have to remember these things are connected in customers' cars with lithium setups all the time, and they fail and they cook the power supply, and it's savable. Yeah, it's fine. You just clean it up.
Right. I'm
Safety
gonna start.
safety glasses. Yeah, maybe you got any safety glasses? I mean, it's obviously in a metal heatsink, so it shouldn't be showing stuff. So the
Yeah.
drill,
All the exposed parts are facing out,
yeah.
so I'm behind it.
So the drill on the amp, that is an impact driver that is mounted, that is inside the power terminal, ready to go woo and pull the wire out if it fails.
Just remind me, it's already set. I don't need to press the rotation. We're not trying to screw it in. We're trying to undo it.
Yeah,
Okay.
don't
Just remind
rotate,
me.
don't rotate.
All right.
Can car tweeters
I'm
really take 2500 watts for real? I would say no. Look at the size of the coils on tweeters. Like, no, it's not taking that much power. But there
right.
we go.
I'm gonna do a let's get this phone recording. I'm gonna do a test run. Let's quickly set this up here like that. All right. Let's go to our chat. Let's grab that file.
Are you playing it through WhatsApp?
No, no, no. I'm saved it to Google Drive.
Okay.
All right. Just quickly do this little run. All right. Restart it. Yeah, cool, perfect. Right, hold up, Sam. I didn't get the privilege of everyone else. I'm actually listening to one of your ads, so I can't actually see what's going on the screen.
Oh, is it playing an ad right now?
Yeah.
Oh, on the stream. That's cool. That's cool. Yeah. Yeah,
All right.
that's fine.
So the first test we got 92 watt. So I'm gonna now
So
increase it.
increase it up. Go from there. See what's cooking.
Normally I stand far away from it. I've got to stand closer to it now to
You
make that
have,
drill
yeah,
useful.
you have.
All right. Let's go again. Can you guys see the numbers? We need to zoom in a bit more.
Probably going to zoom in. So they've seen the amp on the bench. It'd be nice if they see the sparks when it fails, but you could definitely zoom into the SMD. Yeah, zoom into the SMD a fair bit with the oscilloscope. A bit more. Actually, yeah, I think that's good. I think people can see that. Yeah, that's
All right.
good. That's good. That's good. Yeah.
That was 352. We'll bring up some more.
Yeah, bring up some more.
35. I might have to turn up the gain on this amp, you know.
You might have to turn the gain up. Yeah, we set it nice and low, just
Right.
just
I
to
am
start
covering my
with.
ears, by the way.
Is that on 20 volts per division?
No, I need to bring it. Well, it should be. I need to bring up a bit more, actually.
Yeah, you do. It's too high. Yeah, that was 1,000 watts. Was that on this? I can just about see that on my tiny screen here. 18 something. Was that?
Well, yeah, 1082. Let me zoom in a bit
Okay.
more. If I point you down like this, you can see the vents, and then zoom it in like.
Yeah. Cool. There we go.
Right. Let me run that test again, and let's sort out this oscilloscope. Right, it's running.
Yep.
See that dangerous things. All right.
There we go. There we go. Yeah, that's perfect. Leave it on that one. Okay,
Mate,
cool.
exactly the same again.
Yep, cool. So a few more clicks on the head unit. I think go one division up on the scope again, actually, because it's going to be getting big. The sine wave is going to be getting pretty big.
Right.
Can you see the clip light on the amp as well from where you're standing?
Yeah, but with these oscilloscopes, you got to clip it so hard, Sam. I'm talking like a noticeable sine wave. I mean, square wave.
Yeah, just go until the clip light on the amp comes on, rather
Look, this
than
is how the amp's still chilling.
yeah. 23 degrees Celsius. Nice.
All right.
Okay. This is a very slow ramp. I don't like how slow the ramp is. Okay, so we've got just over 2k there, and a fair way to go possibly. So there's your 2k at 4 ohm. So let's keep
Sorry,
going.
sorry about this, guys.
It is a slow ramp, isn't it? You need a quicker ramp.
Should I just? Yeah, that's how these that's how the
Yeah,
track is from the S&D website. Should I bring up the gain a little bit?
you can do. Yeah, is the head
'Cause
unit pretty
I'm
high?
gonna start clipping the head unit soon.
Okay, yeah, bring the gain up a little bit then. Yeah.
Let's try that. All right, I'm gonna go again.
Yep. Bro,
We're get we're getting there.
we're getting there. So
We're
that
getting there.
we're at 3,396 watts at 4 ohm, and the clip light didn't come on.
Right, 40 is as high as I want to go on this head unit
Yeah, that's
until
cool.
now
So
it's gonna
the
be gain.
so the clip light didn't come on yet, did it?
Nope.
Right. Just check the temperature on the amp.
Chilling, bro.
Chilling. Okay, cool. Just let the heat soak away from the FETs a little bit. Just give it like a minute or so. It obviously you're turning the gain up gradually, right?
Yeah.
If like what I want you to do, okay, is that obviously once we find the clip point of the amp, because we don't know what the clip point of the amp's going to be. Once we find the clip point of the amp, the second that clip light comes on, are you able to stop the tone so it doesn't go further into hard clip?
I could just pause it, yeah, or I just turn
Yeah,
on the
is it?
volume.
Yeah. Are you able to like pause
I'm
it
using
really
so look, I'll show
quickly?
you I'll show you what I'm doing. So look, I've got this phone in my hand. I can
Yeah,
either
yeah,
pause
yeah,
it or
yeah.
I can just turn it down.
Yeah, and if you pause it, does it like pause straight away from when you tap it, or is there a delay?
I mean, it's using the Bluetooth receiver, not the head unit, so the delay is pretty short.
Okay, that's fine. Yeah, as long as you can stop the tone when you see the clip light come on, because I don't want it to go into like heavier clipping than it needs to.
What is the sine wave saying? Is it looking?
It
Is
looks
it needs
fine.
more division? Yeah.
It looked okay, I think, just now. Maybe
Right.
give it. Yeah.
I'm gonna run it again, and we'll see what the division's saying. If I need to increase it, we
Is
will.
it have you increased the gain or anything since the last test?
Just one click on the
One
head unit.
click.
So we're now at
Okay,
40 on
calm.
the head unit.
All right, cool.
There we
All
go.
right, there we go.
Yep. So that was clipped. So we only made 3,500 watt
3,585.
85.
Right, who was closest? 3,585 watts at 4 ohm. Nice. Okay,
Do
not
you want to
too
see what is?
shabby.
Do you want to see if it's clean? Should I bring it down a bit, or are you out with that?
That's fine. I
Yeah.
saw the clipping light just come on like for half a second on the SMD. That's fine. That's like at clip point. So at clipping, just at clip point, it's making 3,500 watts. That's cool.
Bro, this
So
amp's running cool. It's not even hot.
yeah, man, them 4127s do be good.
Look, guys, check this out. Look.
Well, it's only 4 ohm, but yeah. All right. So we had Dr. Dyno with a 3750. Let's see who guessed a 3,500. because that will be the closest. Whoever said 3,500 will be close. What did I guess? I think I guessed, didn't I? I said about 3,500. 36 from Elia, 30, 3.6. Latvian video, 3.5k. So the winner is Latvian video with a 3.5k guess. Congratulations.
Somebody write this down. Somebody write this down so I can remove it from the screen. So this was, well, not exactly 4.3, but yeah, 3.5k. Yeah. All right, cool. I'm going to turn this off for now. Where are we going now, Sam? We going 2M?
1 second. 1 second, bro. 1 second, bro. Just trying to find.
How hot did the resistor get? I've got to find what it is. Only 63 degrees the resistor hit.
Okay. Okay,
Yeah,
cool.
That's not too shabby at all, though.
Oh, that is true. 3585 is closer to 3600. So yeah, anyone who guessed 3500, 3600, congratulations, you have won.
And deep it, that's at 4 ohms. That is a lot of power for 4 ohms.
That's not bad for him, yeah. So I suspect that's about the sort of power that I would expect from this amp stock at 2 ohm. So I suspect that yeah, we've just created a 2 ohm version. So I think probably at 2 ohm, this is going to make about 5, maybe just over 5k.
Yeah, so we're pretty much on spec from it being like if it was a 2 ohm.
Yeah.
So run this amp at 2 ohm, it would have got the 3k.
Yeah.
Normally.
Yeah. So that means that the rail voltage is sagging down from 190 to 175 volts, courtesy of Michael there.
I need to keep an eye on the current draw as well.
Yeah. So, gents, then, do we have any guesses for 2 ohm? So, this amplifies 5k at 1 ohm usually with the mods we've made. Obviously, it's going to be a bit more. So, are we going to see the 5k at 2 ohm? Willy Zilly, the stream setup you guys have is very entertaining to watch. Thank you very much, man. It's it definitely works well, doesn't it? It's really cool.
All right, when we're now at 2 ohm, hopefully I ain't done what I've done before with the tar amps.
Morten says 7170 at 2 ohm. I go big. I don't think so. I'm gonna guess about 5,700.
Right. Hopefully I've not wired this wrong because I've done it before in tar amps.
Right. So obviously
I've looped the cable.
Right. So Donnell, the gain and the head unit point that you had for the 4 ohm test, go back about 3 clicks on the head unit, maybe 3 or 4 clicks on the head unit, and start there.
I've zeroed the head unit.
Okay, so what we don't want to do is do that whole thing of gradually building it up again. We just want to go like 4 clicks, like 4 or 5 clicks down from that clip point that you had it at 4 ohm, and start from there.
Tell you what, we'll start 36. We'll start 36.
What did you have it on before? 40.
He was on 40.
Yeah. Start at 36. Yeah. So we've got some guesses coming in. Let's just have a quick look at some guesses. We got 60, 68, 85. Wow, Frank. Got 5321. Got a 60.
Right,
a lot of people are guessing over 6k.
Gonna do a quick test to make sure I've not put the jumper cable on this by accident, just to see if it reads 2 ohm on some low power.
Yep, cool. A lot of people are over 6k. 6.2k. 5.8k from Badass.
Yep, we're at 2 ohm.
Excellent. 5.3, 5.7. Okay. Willy Zilly thinks about 4.9k. I'd be surprised if it was less than 5k.
Oh, it's just reset. Don't tell me that. please keep the same.
So bear in mind, okay, that
Yeah,
on
100.
paper, just before you do this, Donnell, I'm just going to say this to the guys. Just bear in mind, so on paper, every time you halve the impedance, the power should double. Given absolute perfect circumstances with no board sag or resistance or anything. So if it made, what was it, 3,500 watts there or thereabouts at 4 ohms,
Yep.
technically the amp is going to try and make at the same clip point 7k. Now obviously we're going to have a lot more rail sag, so it's not going to make the 7k. It's going to be less, but it's going to try and make 7k. So any power that it makes less than 7k is as a result of losses across the board, transformers, inductors, FETs, etc. So that's what we are trying to find out. Why don't we see the input voltage? It's difficult with your setup, isn't it, to really see all of the stuff on with your
So
single camera.
voltage, we're now starting at 15.3, but the power supply is going down very quick, so we're nearly back at 15.4 to where we started.
Yeah, so about 15.4 volts is what the batteries are floating at. And do you know, did you catch what the voltage dropped to when you tested 4 ohm?
It dropped to like 14.6.
14.6. Okay, so the most important thing is that we're above the regulation point. This amplifier is regulated. It holds the rail at 190 volts, or it tries to hold it freewheeling at 190 volts at about 13.2 volts. So as long as we don't drop below 13, we're not going to be at a disadvantage because of voltage. So that's fine.
Yeah. I mean, I could always go higher.
Yeah, no, you don't need to go higher. I don't think it'll make any difference in this instance. So yeah, let's
Right,
go. Let's go at
right.
volume 36 on the head unit. Let's do a test and see what happens.
Yeah, watch this. Look, I'm resetting it. It's keeps reading 1 watt now.
That's fine. Don't worry about it. Just it can
Yeah.
read 1 watt. It's fine. Yeah.
All right, let's go for it. I'm covering my ears though.
Yep, that's fine. Let's go. Okay. Yeah. 2K, 3K, 4K.
Oh, I heard something.
Yeah, I heard something as well. It's in protect.
Yeah, it might have been current, but I heard a click, and there's no relays in here.
Yeah, I heard a click as well. The click can be output FETs failing. So what you could do, now these amps do have a health check, so you could cycle the remote. You could like lift the remote and put the remote back on again, and it shouldn't kill the power supply FETs if it has got a dead output FET.
Can I do it on low voltage with the bench power supply?
Yeah. Disconnect the battery. Yeah.
But it made 4,147.
Okay. But it wasn't anywhere near clip point, was it? So the MOSFETs that
No.
the MOSFETs I fitted to this just for this test were salvaged MOSFETs. They had been used in a Taramps Smart 5. So these are not new parts. So it could be that they were a little bit
It's not even
weak.
hot. That's the thing.
No.
Look, guys.
No. But it's worrying that it went into protect. Like if the MOSFETs aren't dead, it's worrying that it went into protect.
Bro, I know there's no relays in here, and I heard a loud click.
Yeah. I suspect
cool.
I suspect the output FETs might be dead, and it's just unfortunate. Maybe they were just a little bit weak from the ones that I had laying around to use for this experiment.
Right. If you don't mind, I am gonna undo the big power cables.
Yeah, go for it, man.
Yeah, we'll get it on some low current, and we'll see what went wrong.
But if you guys like this, if this is entertaining, then if the output MOSFETs have failed in this instance, I'll get Donnell to send it back to me. I'll load it up with some new FETs, some really powerful ones, and provided the stream or the video makes enough money to cover the cost of the FETs, I'll load it up with some big FETs, and then send it back down, and we'll do this again. If you're enjoying this, if this is like a fun format.
Nah, for real, this was really cool. I really enjoyed it.
Yeah.
All right, let's undo this one. Yeah, but do you know what? Fair play to the protection circuit, to be honest.
Well, yeah, that's the thing with these modern amps. It rarely kills the power supply when the output section goes down.
Yeah, no, fair play to it, because literally, as soon as I heard the click, See the numbers there, 4,147.
Yeah,
That was it.
yeah.
Or hopefully it's output effects. Right.
If it is output FET, if it's one dead output FET, you could actually cut it out and we could continue just to see what it will do on the remaining FETs.
We'll cross that bridge when it comes to it, bro.
Yeah,
Let me
yeah,
just see
yeah.
what's going on with it. Right. Unplug. What's the chat saying? I can't see it from here.
Chat is saying it's protect, blinking, blinking. Chat is saying that Michael says, Michael, my guy here in the chat, is very clued up. Probably knows way more about amplifiers than I do. Seems to know his shit. Says it could either be output overcurrent limit if it has that, or perhaps input
That's what I was
overcurrent.
thinking.
Input overcurrent due to the transformer saturation. The click could just be the output filter inductor when the signal suddenly dropped. Yeah, exactly. So I heard the click as well, and I know that your microphone has noise suppression, so
Yeah,
I know that was a loud click. I know that was loud, and I've heard when an output MOSFET shorts, if it doesn't explode, if it stays intact, the sound of it dumping all of the energy from the rail caps through the FET to ground, it causes like a loud click and ring through the heatsink of the amp. It's like ding. You're like, whoa, okay, what was that? It sounds like a relay almost. It's very loud for there not being any mechanical parts in there, and that's what it sounded like. So I've got a funky feeling that it could be.
Yeah, it was very
It could
loud.
be a dead output FET. These amplifiers don't have any current sensing on the power supply side. There's only current sensing using the IRS 20957. I think does that one have overcurrent pin? I know the 2092 has the overcurrent pin. Can't remember off the top of my head if the 20957 has it, but it uses that for overcurrent. And based on the fact that we have just increase the rail voltage and we're doing this at 2 ohm, the current even at 5k should be less than it was at 1 ohm 5k, so we shouldn't have triggered any overcurrent protection circuits. So yeah, I think that we might just be looking at a dead output MOSFET here, which is a shame if it is the case, but we will cross that bridge if we come to it.
Sorry about the long time setting up. I'm trying to find my banana plugs, but I can't, so I'm gonna have to go bare while.
That's fine.
Don't worry, guys. I'm not gonna crank it down.
Jay Holm, how's it going, my friend? B2 Audio in the chat. What's good, bro? Jay, just to bring you up to speed. So, customer sent in a Bassface Team 5K. It's just a generic Chinese clone of the Sound Digital circuit, same as the SFB 5K. It was blown to bits, and it had a failed transformer in the power supply, and you can't really get those. So he said, "Nah, just leave it." I had a blown Sundown SFB 13.5K in the loft that uses the same size transformers. So I was like, that's going to be quite funny. What happens if I use some of the transformers from a SFB 13.5K in the Team 5K? Obviously, the rail voltage is higher, so I modified the rest of the amplifier, changed the rail caps, changed the output FETs, changed the regulation circuit point, changed the overcurrent, modified the rest of the amp to allow for a much higher rail voltage in this little 5K. And essentially, it should have on paper kind of made it into a 5K 2 ohm version rather than the original 1 ohm version. So I don't have any high current bench test abilities here, so I sent it to my good friend Sinewave02, who has big lithium banks in his test setup, to do some dyno tests on it and see what kind of power this random Frankenstein amp that's been modified can actually produce. So far at 4 ohms, we got 3.5k at 4 ohm. So we are en route to do hopefully around 6k at 2 ohm, and then God knows what at 1 ohm. But the parts that I used, because this was just a bit of a fun experiment, were just salvaged parts that have been used previously in other amplifiers. The output MOSFETs came from a Teraamp Smart 5, so they have been used before. So unknown health condition of those output FETs, but they were just ones I had laying around to chuck in here for this fun experiment. I was fully expecting this amplifier to fail on this stream because we were going to keep pushing it to 1 ohm and see what crazy power it could make. So So, but it would be a shame if they have failed already. If that's the case, it suggests that they were a bit weak from the previous use in the Smart 5. But that's fine, because this has been like a nice little test of this video stream format. And
Yeah,
if they
it's
have
been brilliant.
failed, Donnell can send that back to me. I'll fit some really beefy FETs and send it back to Donnell, and we can go from there and do another stream just like this and see what kind of power we can get out of it.
All right, what voltage should I power up at? I'm at 10.5.
Yeah, power it up at low voltage, like
Let me just check
yeah,
my
10
wiring,
is
make
fine.
sure nothing's back to front. So we've got positive here, going into positive. Oh, no, it's just fell out. And then what's the negative? Negative is going into negative. And then
Michael says,
remote.
what should have killed the MOSFET though? Rail too high. So the rails are fixed at 190 volts. These MOSFETs are 200 volt with an avalanche rating of 250 volts. They're sturdy. So the over voltage, the voltage wouldn't have killed it. I suspect that if
It's pulsing again like it was before. It might even be
okay,
fine.
yeah, let's see. If it's fine, then it's confusing why it went to protect though.
I'm up 14 volt. Let's see if it builds rail. I've got a weak power supply, guys, so
Yeah, so
sometimes it
it's
takes a while.
Donnell's he's disconnected the lithium battery just for safety, and he's connected up a low current bench power supply, which takes a little while to build the rails for the amp to actually turn on. So let's just see what it does.
Yeah, I don't think that's building, bro.
You should be able to tell by measuring the voltage across one of the speaker terminals and the amp ground terminal, because it should be building a bit of half rail. If you get close to 0 volts, then yeah, there's a shorted output FET. If there is
Let's
a
try
shorted
again.
output FET, then that's going to be really exciting, because then we can get Donnell to take the back off and cut out the dead FET and see if we can complete the test on the remaining surviving
Right,
FETs.
we're at 14.5. We're at 14.5. Yeah, we'll try again.
Okay. Please make a video if you do another test of this. Yeah, definitely. We'll be doing another live stream regardless. This is really fun. I've got really high concurrent viewers, so this is clearly something that interests you guys. This is the first time we've tried this format of live. So if you guys enjoy this, then we'll definitely do more stuff like this in the future for sure. And if this amp has failed just now, then that's fine. We'll do another one when it's got some brand new, much beefier MOSFETs in. But stick with us just now, because it might be fine, and we might be able to get Sinewave02 to cut out the dead FET, if there is a dead FET, and continue to see what it can do on the remaining ones.
Yeah, bro, that's not building. There's
Yeah.
there's an issue inside.
Okay, so right, disconnect it from your power supply, then flip her upside down, unscrew the back, grab your multimeter, and let's see what's failed, and let's see if we can get it back up and running temporarily. Dude, do you have any MOSFETs laying around that, in this package size? Because I know that you've definitely like taken apart amps before, like, and stuff.
Yeah, I've got some out the crown, which I think are similar.
Oh, the crown. Does that use 4427s? But I don't think it uses 8 of them though.
I'll have a look. No, but if hopefully only one's died.
Yeah, but I don't think the crown uses the same FETs as what I've put in this. I've put IRFB 4127s in this.
Yeah, no.
I think the crown might be using 4227s.
Right, let's open up and let's have a look.
Yeah. Zoom out on your camera, and let's get everyone get everyone to see what you're doing. You could use IRFP 4768. I don't know that part number by memory, but I believe that's a TO247AC part, which is a bigger package MOSFET. We could use that. The only annoying thing is that obviously the MOSFET is bigger, so the MOSFET clamps won't fit, so we'll have to drill and tap some new holes, which is definitely possible. That actually might be something that we'll do. If this amp has failed, I'll probably fit some maybe some 4868s. Oh no, I could fit some IRFP 90 N20Ds. Those are pretty beefy FETs. Those are what are used in the Band of Viking 8K, which makes 10K at 14 volts. So yeah, 8 of those will definitely support more than enough power for this mod and this test. Sam, would you ever come to visit the States? I've been to the States once before. I came to visit Digital Designs. I went to their factory. We had a little tour. I stayed with them for about a week. We did some fun stuff, did some videos. So that was Oklahoma, and I also went to Dallas for Knowledge Fest. That was a good time. Yeah, whether I'd come to the States again, maybe. I'm pretty busy these days, but who knows?
Gonna need this probe to check. How many rectifiers in here, Sam? Is it 2 per side?
Right, so you got do a little zoom in on the board. Yeah, you've got four output MOSFETs
Oh
per
yeah, yeah.
half
Let
of the
me.
bridge.
Oh, my bad, guys. My bad. Let me take you more
Yeah,
forward.
yeah. Do like an overhead view like I do on my streams.
Yeah, I got you guys. Don't worry. I got you. I got you.
Would love to plan you to come over. Set you up for a little come see the operation. Yeah, we can definitely chat about a few bits. I don't think it will be any time in the near future, but yeah, it's definitely something we can talk about for the future, perhaps.
Right, is that? Can you guys see that? All right, yeah.
Yeah, I think you're going to need a little bit more ISO or a little bit longer frame timing. What's it called? Yeah, a bit more brightness, a bit more light on the
I can bring
camera.
you more over. I can bring you more over it.
We just need more light. So turn the ISO up or reduce the shutter speed, the frame speed. What's it called? Shutter speed. Yeah.
Is that okay?
Yeah, that's better. Yeah. So grab your multimeter then, and just like we've done before, continuity mode so that it beeps when the leads touch.
Yep.
Okay, and going from left to right, start on the bottom 4.
So these, yeah.
Yep. Can you put your multimeter somewhere where the camera can see it? Just put it on top of the transformers. Transformers.
Okay.
Yeah, skiing. Oh, now we've got a big light reflection. Okay, put it.
Can you not see it like there?
There's good. So yeah, test. Put it across leg 1 and 3 of that MOSFET on the far left.
No beeps.
No beeps. No readings either though so far.
I'm not seeing anything.
Okay, flip the probes round. So flip the probes round. Okay.
Nothing.
Should be
Middle leg.
Right. Okay. Next one along. Yeah, the rail caps will be empty. They empty pretty quick. Next one along. Are you going between leg 1 and 3? Yeah.
Yeah, this one here, and this one here.
Yeah.
I'm touching the screw.
Yeah. Next one along. Next one along.
Nothing.
All right, now do the top ones. The 4 on the top. You have to move the multimeter.
I'm going to be covering this. I'm going to have to go around
Is
the camera.
Is it in diode mode?
No, look, it's on. This is continuity mode.
Oh, okay. Does it beep on diode mode as well?
No, shouldn't beep.
Now leave it on continuity mode. If the FETs are dead, then you'll get a continuity, so that's fine.
I think that's the problem.
There we go. Right. So find the one that reads basically a dead short. There'll be at least one that reads a dead short. So some of them might read a bit of resistance, like maybe
That one.
That one.
0.15.
All right.
No,
What was the one next to it? What was the one next to it? Was that like 25 or something?
I'll show you. Look, can you see that? Yeah.
Yeah.
Watch this. That's 26.
Right.
Look at this one. Ready?
Yeah. So the one that's dead short. Yep. Grab your cutters, bro. Grab your cutters and chop that bad boy out.
You know, I need to go find them. You know, I haven't put the cutters. So you want to continue with this, yeah?
Maybe if the drive circuit survived. Yeah. Well, I mean, obviously we're 1 FET down, but it'd be really interesting to see what it can do with 1 FET down.
All right. Hopefully, it's just that one that's gone.
Maybe.
Wait.
You should also test.
No, Sam.
What?
No, we've melted one. The leg completely off, bro. Look at this. I'll bring you guys over. Let me take this camera off the mount.
On the power supply side, maybe.
No, on the output side. Look at this, guys.
Side.
Where is it? Where do I see it? Yeah, right here. Look.
Sheesh. Well, I never. So that won't have happened during operation. That will have happened at the failure point. So the MOSFET shorted and then fused the
that's
leg.
definitely what I heard. That's
Yeah,
definitely
yeah,
the
yeah.
tink I heard.
Shoo! All
That
right,
was some current
so
going through there.
yeah, man, for sure. Holy bananas.
So
So
if that one's shorted as well, that means that one next to it shorted, or maybe not. I don't know.
well, so cut out obviously the one that's got a bad leg. Cut that one out, and also the one that was reading low, and then see what you got left.
All right, bet. Put you guys back on there. So let me just confirm it was this one and this one, wasn't it? These two.
Yeah.
Let me just confirm that. Hold up. I don't know. It was the one with the missing legs over here. I think they're all gone, Sam.
Yeah. So cut out any of the ones that are reading like very, very low, like 0.1.
Right. So undo the cover, the clamp.
You don't have to.
Bend it out of the way. Oh, that one just disintegrated in my hand.
Yeah, make sure the legs aren't touching each other or touching anything. Just have them floating.
That's what I'm doing,
in
yeah. Right, I'm now not getting a short anymore. On that one, at least.
Yeah. Cool. All right, so yeah, get that other beeping one chopped as well. Let me just read some live chat while you're doing this. There was definitely some chats going along here. How much is a whole? How much is a whole batch of power and output FETs to refit this? So the power supply FETs are fine, thankfully. Output side, 8 FETs. I don't know. We could have a little look in a minute on the internet and just see what it would cost to put some really big beefy FETs in here. But I suspect if we put 8 IRFP 90N20Ds in this, then we might be looking at, I don't know, maybe 30, 35, 40 quid, something like that.
Hey, bro, I'm not gonna lie. I think this whole top side here is all gone as well.
What do you mean?
I don't think it's gonna be. There's not gonna be enough really to run the test again because the man's cut bare out. Look,
there's only two.
This one's fine. Yeah, this one's fine.
Yep.
This bank's fine. So there's only one left in this bank. There's one left in this bank. This whole bank here.
No, the next bank along is no. The next bank along is the rectifiers, bro. Don't touch those.
Yeah?
Don't touch those. Don't cut those. Don't touch those. There's only 4 MOSFETs per side. Don't go any further than 4.
Right, well then yeah. There's only 2 left.
All right, cool. So now with your low current power supply, connect it back up and see if it comes on and idles.
Right. Cool. Ground. Let me just make sure the legs are completely gone away from that.
So I think that these MOSFETs that I fitted were salvaged ones. Like I said previously, they were used in a Tyrant Smart 5. I think that they were weak, and they were weakened as a result of being used before, because they should have definitely handled this with no issues. So
Sam, I need tweezers, man.
Yeah, just cut the legs off so they're not touching anything, and it should be fine.
Yeah, so I'm checking now. It should be, yeah, it's all good.
Adrian says, Beverage, throw out an estimate on refitting of the FETs. We can shoot over some super chats to pay for it. All right, well, let's have a look on the internet and see what we can buy for this. Like, I do have lots of salvaged 90N20Ds. Like, look at this. Look at this massive drawer, which I can't even get out of the bloody thing because it's so full. I've got probably like 50 salvaged 90N20Ds here. So I could use some of those, but obviously I don't know whether they are weakened or damaged. So it would be nice to buy all new ones, wouldn't it? You know? Visit states. The outputs from the Tyrant's 15K works in the MD8K with a little tweaking. I'm sure it does. That sounds pretty cool. Tyrant's 15K, aren't they IGBTs? If you build an amp that works amazing, will you sell it? Yeah, but that's a long way off. But yeah, I'd like to.
Alright, Sam, it still won't power up with that, so let me keep checking the other side.
Well, no, it might be the drive circuit has failed.
Yeah, probably.
Right, with your multimeter, put it onto voltage
Yeah.
mode. Put it on DC volts. Yeah, the RFP 4668 is more powerful. Yeah, yeah. So I'll have a look on the internet in a minute and see what we got.
I'm taking it you want them to power up then, yeah?
Yeah. So what I need you to do is I'll need you to be probing with the multimeter. Shove the black probe in the ground. You can just use the little hole that's on top of the terminal. You know, there's a little screw hole on top of the
No,
terminal.
I'll put it in the ground.
Yeah, okay, yeah, whack it in there. And then the red one, you want
Yeah.
to touch it on, there's a specific point on the board that I can't quite see because I can't see it, but you want to touch where the rail is, and it's going to be, right, so you know there's 4 output MOSFETs.
Yep.
Yeah, so it will be the middle leg of MOSFET 3 or 4, either of those two.
So
Yeah, the
that
middle
one there,
leg
yeah?
there, yeah.
I'm
Just
gonna power up, yeah?
hold it there while powering it up, and you should see the voltage start to climb if it's building rail.
No, it's stuck at 14.51. Yeah, it's failing to build. Oh, you can't even see it, my bad.
No, that's right. I believe what you're saying. 14.5. Okay. Check the voltage on MOSFET 1 or 2 on the middle pin as well while it's trying to power up. Just careful not to slip your probe.
Yeah, 14. Oh, you slipped there as well. 14.94.
Okay, well, what about the other side?
Yeah, it's the same, 14.94.
Okay. So
Yeah, I think it's
I think I
definitely had.
think I think drive circuit has failed. That's fine. So that's cool. No worries.
That's
What we'll
cool.
do.
It wasn't catastrophic, which was great.
No, it wasn't catastrophic. So what we'll do, guys, just real quick on the stream right now, is let's have a look online and let's spec up some big beefy ass FETs for this, and let's get Donnell to shoot that back to me, and then we'll make some beefier mods with some new parts that aren't going to fail, and then we'll do this again. So let's go to RS to start with, and let's go to electrical components, semiconductors, discrete semiconductors. And let's go to MOSFETs and let's have a little browse, shall we? Hang on a minute, my face is very not in the frame for some reason. Hang on a minute, let me just sort that out. There we go. Right, so we want maximize, we want maximum drain source voltage, we want 200 volts, and we can go 300, but the chances are that the 200 volts are going to be better, so we're going to go 200 volt and 300 volt, 250 as well, why not? And we're going to do mounting type through hole, and we're going to do channel type N, and we're going to do package type. The thing is that there could be many different packages that we could use here, so I'm going to go for, actually no, let's just see what we've got on here, and we're obviously looking for high current ones with low RDS and stuff like that. Actually, why have we got that one come up? That's a surface mount one. MOSFET, right, here we go. So the MOSFETs that we had fitted, the IRFB 4127s, these should have been enough, but like I suggest that they were weak. They were 76 amps. So let's go to maximum continuous current drain, which isn't how it works in Class D, but it gives you some rough idea. So we're going to go from 70 amp, and let's just go all the way up to whatever its maximum is. Let's just keep going here. We obviously need something fast enough to work with Class D switching as well, so we can't just put, like, you know, whatever in there. Okay, there we go. So we have all of our filters selected. Now, the cheapest one, I think I've set by price. If I set by price, Lowest first. So the cheapest ones we've got are these IXTH94N20s. They're 94 amps continuous. RDS is 0.106. TO247.
I was getting interested, man. Gave me an advert again, Sam.
You aren't sorted right now. Yeah, we are sorted. Click on price again. Oh, yeah, no, I wasn't sorted. You were right, I wasn't sorted. Strange. Okay, my bad. I thought it was. Okay, the cheapest one's then IRFP 4127. So that's the same FETs that we were just using, but this is in a bigger package, so they're going to have more power dissipation. Interesting. Okay, let's just open that up in a tab. So that's pretty cheap, actually. If we were going to load that up, that's going to be 8 of those, about £13. £13 including VAT. Let's keep going and see what else we can come up with. We have this one here, which is 150 amps, so that's a fair improvement, but that's don't need 500 of them, so let's just keep going. Let's just keep going. Don't need 50, don't need 50. STP75 NF20. Let's open those. They're very similar. DB Audio with a 799. We also had Is6 with a 420. Dummy loads, be not forgiving. Absolutely, I agree, my friend. They are not forgiving. Thank you so much for your kind donation there with a 420, my friend. Is6. Thank you very much, and thanks DB Audio for a 799. I'll pay for the first couple of FETs. You legend. Thank you very much. That's very kind of you. Big up, big up. Let's keep going and let's keep scrolling. So we have don't need 30. We have these ones. Here we go. These are the first 247 package ones that we've come across. Let's have a look at the data sheet for this bad boy, and let's see whether it will be fast enough to work. So, comparing it to the original ones that we were using just now, if they had been in good condition, power dissipation 375 watts. We have a pulse drain current of 300 amps. We have an RDS of about 20 milliohms maximum. And they're relatively low-ish input capacitance, 5,000 picofarads, and the timings are very fast. That's pretty nice. That will contribute to the low idle current. Gate charge isn't too bad either. So let's have a look at these bad boys then. What do we have? It's Mitch from Australia. What's going on, Mitch? Yo, thanks for jumping on. I didn't recognize you by the name. I'm terrible with that. Apologies. So we have 74 amps continuous, 200 amps pulse. So the pulse on these bigger ones is actually a little bit less. Shouldn't matter too much. The power dissipation is more. Obviously, these are a bigger package part. That's cool. And how about so the input capacitance is lower. That suggests possibly a smaller die size, which would make sense for the pulse drain current being a bit lower. The timings are nice and fast, and the total gate charge is probably low enough as well. Can't see where that is just now. Here we go. Yeah, that's low enough as well. So these ones will work perfectly fine. So let's just drop 8 of those into our basket as well for comparison reasons. But we could definitely go for something a bit nicer. These ones aren't in stock. For some reason, RS doesn't let you filter by ones that are in stock, which is my most frustrating thing about this website. But there we go. Let's keep having a look, scrolling down. We have these ones again, £3 each, 150 amp. Here we go. These are getting spicy. So these are in stock. We'd have to buy 20 of them, annoyingly. Can we? Wait, it says 2. 2. Can we not just... Please enter as multiples of 2. Well, yeah, I have. Right, the minimum is 20. Well, okay, that's no good. I don't want to buy 20 of them. Let's keep going. Here, what about this one? Okay, here we go. That's better. Right. So £6 for a pair of these. Let's open the data sheet. Let's have a look. We have 200 volts, 150 amp. The pulse drain current again is a little bit lower. The power dissipation is good for a small package part like this. The input capacitance is good, that's low enough, they're fast. So these are looking like a good potential. It's a trench FET, power MOSFET. These are looking like a good potential. Let's slap some of these in our basket. We need 8 of those. Okay, fantastic stuff. Let's keep going. See what else we got in here. 25, 25. We have IRF 300p 226. What do we have here? Data sheet. These are 300 volt part. Okay, so a bit of headroom on there in terms of voltage. The current is 100 amps of continuous current. 19 milliohms, so it's nice and low on the RDS. 556 watts maximum power dissipation, not bad. Pulse drain current is nice and high. The input capacitance, oh, 10,000 picofarads input capacitance. Shee! Okay, I don't think we can use that. The drive circuit is going to be complaining, not happy. I don't think, well, I mean, they probably work, but they're going to be getting a bit spicier idle, I think. I don't know about trying to use that. That is some next input capacitance. I mean, we could probably get them working, but I don't know. That's a bit risque. Yeah, we'll bench those. Not convinced about those. Let's go a little bit further down, see what else we come to. Come to these ones, the STWs. I think I put those in my basket already, didn't I? What we got? What we got?
Hey, but Sam, you got to big yourself up though. You thought it was going to explode. It didn't.
Well, it did fail.
Yeah, but it didn't explode. It didn't set on fire, so I'm happy about that. No smell.
Okay, here, these are different ones again. 75 amp. These ones are very similar to the effects that we just had in. I want to go bigger than 75 amps, so we're gonna step it up a bit. Let's go much bigger than 75. Let's go for more like. You know what? I think these ones that we found. I think where was it? These. I think these ones that we found are looking like a fair shout. No, was it? No, it wasn't these. It was here. Here we go. These ones. These ones are looking like a fair game. All right, let's have a look in our basket and see what it's going to cost for these. So these are already the correct package type, which is nice. It means I haven't got to do so much modifications. Yes, delete. Yes, delete. So we can drop 8 of these bad boys in. That's going to be 24. I'm just going to sign in so that we see what it, because I've got an account, so I don't get charged the admin fee. Okay, so this is what it would be with me logged in. So for 8 of these, we're looking at 33 GBP. And what drivers does this use? I feel like this uses IRS20957. Can't spell. 20957. We need a couple of those, probably. Can only buy 10 of them at a time, no worries. Do be like that sometimes. And we're going to need a couple of drive buffers as well. What are those? I've got them on my email. The 3006s or the 3005s. 3005 MOSFET driver. I think it's like ZGX or something. I can't remember the exact part number. I have to Google it. I can't remember what the model number is. 3005 MOSFET driver. Here we go. ZXG D3005 or the 3006. Either of those will be fine. Let's see what we got. 10 of those on a reel. What about the 6? The 6 will work fine as well. Can only buy those in packs of 25, so we'll stick with the 10s. So in order to rebuild this amplifier then with some beefier output MOSFETs, it's going to cost me not quite £61, because obviously we're not going to use 10 of these drivers. So it's going to be somewhere around the £40 mark. So yeah, 40 quid to rebuild the output section on this, and then we can do this test again.
No, that was sick, man. That was wicked.
Yeah, it's pretty good, pretty good fun. It's a shame that the drivers failed. Do you have any drivers? What Dyno amps do you have laying around?
I've got loads of them in-phase ones.
Yeah, hang on. Don't need the in-phase use 209. You got any Brazilian donor boards?
No, I do not.
Have you got any? What PA amplifier donors have you got? You got Crown, haven't you? I wonder if that uses 20957.
Oh, actually, let me have a look. I have got a special little thing that's got some crown components in it, but I don't know. I don't know if you can see in here. I don't know if you can see
Yeah.
that.
Got any drivers? Got any
Hold up, because I'm delayed.
Hey, bro, Adrian with a 49.99. Gee, my guy, that is some next donation. Dude, I
All right,
appreciate
one
that.
more.
That is very kind of you, my friend. That covers the parts for sure. Absolute
Big up,
legend.
Adrian.
Big up,
Legend,
Adrian, my
Adrian.
man. Sponsoring this shit. Oh, damn, that's crazy. Let's get them parts ordered still. So delivery is free on this. Yeah, wicked. So let's go ahead and get these bits ordered, shall we? 3005s, 20957, and these output MOSFETs. Should we order anything else to beef this up? The power supply MOSFETs are already pretty beefy. The rectifiers will be enough. We know that for sure because there's bigger amps that just use that number. Output inductors I'm going to swap out for the ones out of the SFB 13.5K. What else? Rail caps don't matter. Board trace thickness. Yep. A 10 from Elliot, my guy. Thank you so much for your donation. We've more than covered our parts now. Awesome.
Big up,
Big up,
Elliot, man.
man. I appreciate it. Thank you very much. Very, very kind for your donation there, my friend. In getting this game up and running. Appreciate you as always. Thank you very much. Emra says resistors. I've got tons of resistors in stock, and the resistors aren't current passing components, so that's fine. I've got enough resistors. The only thing that will be dead in this will be output FETs, drivers, drive buffers. I've got tons of 15 volt Zenas already if we need to swap those out. And 4148s, I've got tons of those as well. Yeah, so
Sam, do you know what we should do?
what's that?
If I send back the Bassface and the tar amps for next video, in case it goes again, we could also disable the smart on the Big Boss 3K.
Yeah, could do. Disable the
See how much power we
smart.
can get out of that.
Disable the smart, yeah. That's interesting. I would have to draw some current from the smart in order to confirm that I've disabled it correctly. But yeah, that's definitely something we could do. That'd be interesting.
Because we know I've seen it go way above it, so I know we
Yeah,
stand more of a
it will do
chance.
it. Yeah, it will do it. Yeah,
Yeah,
it will.
we stand more of a chance. It'd just be the heat and the
Well,
time. And
we could do, but the thing is with that is that the Taramps Smart 3 is basically just a Taramps base 3K. So if we want it's a 3K2, it's a Taramps base 3K2 ohm. Did I make those?
I'll give you
Taramps.
the Big Boss 8K then. We do it to that.
Well, it's the same again. It's just a Taramps base 8K 2 ohm version. That's what they are. They are a 2 ohm amplifier with a current limiter installed. So if we want to know how much power it will make without the smart circuit, then just buy the base version. Yeah, it's not something that I think would be. What's the word? It's not going to be like a unique situation that we couldn't achieve by not spending the time doing that. Do you understand what I mean?
Okay, fair enough. Well, if there's any
Taramps
other amps
base
out there,
3K 2 ohm. Let me just see if they do a 2 ohm version. I think they only do a 1 ohm version. Yeah, but it's basically it's the same as that. Are there any MOSFETs you could get which are greater than 90 amps? Yeah, probably. Like if we go back to our list here on RS components that we filtered by, if I go back here to our filtered list, and if we go, let's do maximum continuous drain current. Oh, hey, the ones that I selected are actually the highest current ones anyway in this voltage range. Damn, really? Look at this big chunky boy though. This is a massive package FET. We wouldn't be able to fit those in the
yeah, that
heatsink.
is wham.
£9 each. What's the datasheet saying for that? So 150 amps, continuous current draw. What? The power dissipation though, cheap! My fucking 1,300 watts continuous power dissipation. My guy, Jesus, that is chunky. Right, okay, mint. I mean, that doesn't matter too much because we're doing dyno tests, so we're not going to be saturating, you know, it's not going to matter
I
so
know,
much about that.
but we can always reuse them in different projects because we know that's not going to fail.
Yeah, but yeah, they're not going to fit the heatsink anyway. They're fucking massive. But either way, that's a beast. Shee. What else we got on here that's going to be impressive spec wise? Pulse drain current. See, pulse drain current isn't even that high. So the actual die in this MOSFET is not going to be that much different to the one that we've selected in the smaller package size. The only difference is here is that the package is so much bigger, so there's so much more ability for it to dissipate energy as heat. So that's fine. What else we got? That's another similar kind of vibe. So yeah. Oh, hang on a minute. 200. Wait. 210. Why is that higher? I thought I filtered by maximum continuous drain current. I did. What is wrong with this website, bro? What is wrong with this website? Suddenly we jump up to 210. This is a big chunky boy. This ain't gonna fit. Let's find something that will fit. Here we go. 220. Right, these would fit with a small modification. £16 per MOSFET though, bro. Shee. Supplied in a tube. Let's have a look at the data sheet for this thing. Taramps are super hungry for power. They're not. Stop saying that. You're going to make me angry. They are not hungry for power. They're just big amplifiers. They're just powerful amplifiers. You need power to make power. They're not. By saying an amplifier is hungry for power suggests that it's inefficient. That suggests that it needs excessive amounts of current from the supply to make a given amount of output power. They're not. They're not hungry for power. They're actually very efficient. They actually make very good use of the power that you supply them with. So I don't like it when people say that. They're not hungry for power. They're very efficient. They're just bloody big amplifiers. Anyway, this bad boy right here, 220 amps continuous with a 400 amp pulsed. 800 watts dissipation. This is the chunky boy, but you see, in order for, like, if we wanted to use something that was as ridiculous as that, that's just going to get stupidly expensive, like, because it's going to get really annoying. You know, for us to fit 8 of those, they're not even available in stock anyway. We can only buy them in packs of 5. So that's going to be like that's going to be like almost £200. That, like, no, we're not doing that. You know, so we're going to have to be a bit sensible here with the parts that we fit.
No, for sure.
Yeah.
I can't lie, I've never seen like a leg of a FET disintegrate though.
I've seen that quite a few times, yeah. Especially with lithium, because you've got so much impulse current available there.
Yeah, also some chunky boy cable as well.
Would water-cooled base amp? There have been companies that have done that in the past. The thing is with amplifiers is that how to explain? Basically, no. Basically, it's pointless. Yeah, I don't think that it has any point in water cooling an amp. Since we're talking about taramps, have you any idea why the Big Boss 8Ks keep blowing up? I had 3 buddies of mine run them and all popped and warranted several times. So the only known issues that I've seen with the 8Ks that I've come onto my bench have been some of them had a weakness with the output inductor and vibration damage. The output inductor would snap off if the amp was mounted to the box, but that would have been probably, you know, that wouldn't cause the amplifier to blow up in smoke and stuff, probably. So I don't think that's your issue here. There was a batch of Smart 8 that unfortunately had bad rectifier diodes. That wasn't Taramps' fault. That was a bad batch of rectifiers that they bought from, I think it was Infineon or whatever the electronic supplier is. So unfortunately, a lot of power supply sections were blowing up because the rectifiers would short. That might be the case there on those ones. But apart from that, I'm not seeing like a pattern in them being specifically weak in terms of the power supply or the output side being undersized or under-spec'd for what it needs to do. The only times I've seen them blow up is with the rectifier issue. So yeah, not really too sure on
Yeah,
that one. I like. I'm
yeah,
not
they've been
saying that.
great for me.
Yeah,
It's been wicked.
I'm
I've
not
been
saying that
seeing
they
Dyno
aren't.
vids.
I'm not saying that there aren't issues that there might be with them, or use cases where they aren't doing so great or whatever. But I just haven't seen that, and I haven't had that experience personally, so I can't really comment on that. Da, da, da. So, okay, let's get these parts ordered then, shall we, ladies and gentlemen? We need some 20957s, some of these little drivers. Let me just check my drawers, because if I already have 20957s, then I'm not going to order any more. Yeah, right. So I've got a reel of 20957s, so I'm not going to order any more just yet. That's fine. So we're going to remove those from our basket. Doesn't mean that it's not costing me, obviously, because obviously it is still costing me, but just don't necessarily need to buy any more. And the 3005s, let me just see if I've got any of those in here.
I'm not gonna. I did have an IRF, but it's a 20928.
20928.
Yeah, it's an IRS 20928.
I don't think I've come across that one before. IRS 2092. You sure it's not 2092S? I think it's an S,
Oh,
not an 8.
yeah, no. From this, it's so tiny. Yeah, from an angle, like an 8.
Yeah, it's 2092. Yeah, no, I don't think this. I don't think the amp uses 2092s. I think it uses 20957s. So yeah, that's a shame. What do I have here? I do have some 3005s. Cool. I've only got 2 left though, so I do need to buy some more. So we will order some more. So yeah, I will go ahead and purchase those. Yeah, so let's do it. Let's check out on this and let's get these parts ordered.
Also, guys, in the next run, what do you guys want to see? Like the current, the voltage at the amp, the voltage of the
So
dyno. 'Cause I've got loads of the LF audio meters that I can have probing different
yes,
parts
I
and all
think
that.
this would be a great. Oh, what's happened to your camera, bro? Have you gone? Oh wait, no, it's my bad. I think I just had you.
It's just sitting there. It's
Yeah,
just sitting there
no,
anyway.
it's
It's
fine.
not really
It
doing
was my
anything.
fault. I had you minimized. What I was going to say. This seems like a really interesting stream. People are liking this. Okay. So what I think we should do. This would be a great opportunity, obviously, for you to show off your LF audio meters as well. So I think that
Yep.
send that amp back to me. We'll do some upgrades and some modifications. In the meantime, you play around with getting some meters and camera setup in a good way with some good
Yeah,
lighting
for
that
sure.
looks really good, that you can see the meters really, really easily.
Yeah.
And then once we've done the mods and fitted some parts, then we can do this again and see what's cracking. What just let me just ask the live chat real quick. What would be the best time, day and time for us to do this kind of thing? Obviously, this is a Wednesday evening here in the UK, so I think evenings in the UK are going to be best because then it's daytime pretty much everywhere else that are watching. But maybe a Saturday, would that be good? Saturday, most people would be free to watch perhaps during the day. Let me
Yeah,
know.
Saturday is good.
Let me know. I'm just going to do a cheeky price comparison on a few different websites though before I order these, just in case it's like going to work out cheaper.
What I'll do as well after the stream, I'll grab the sound from because I had an overhead camera. I'll grab the sound from that so you
Yeah.
guys can hear it.
So it wouldn't be this Saturday. It would be like probably in a couple of weeks' time, obviously, until because I'll need to do the mods, get the parts ordered and stuff. But yeah, just in general, what days are best for people? And then we also need some of these.
Probably best thing to do is just once you fixed it, then think about a day you want to do it. Schedule it in advance.
Out of stock. So I'm just going to need like let's just order 10 of these.
These adverts are going hard. Can't lie.
6. What adverts are you getting?
Games, the little you have to jump like shoot the zombies in that
Oh right, yeah, shitty
the
mobile
multiplayer
games.
game.
Yeah.
Yeah.
All right, what are we saying in this one? Just see. Oh no, we need 8, not 2. So, okay, that's looking good from that supplier. And then drivers, we've got 305s versus 306. It's cheaper to get the 5s. And what about shipping wise? We're £7 shipping on both of those. That's a pain. That's a shame. Okay, let's get rid of that. Get rid of that. Okay, free shipping. Excellent. £36 versus what are we looking at on RS? That's loads cheaper. £24. Okay, no, I think we get them from RS. They are cheaper on RS, and the driver as well. Yeah, cool. Cool, excellent stuff. I don't really care when, but it would be help if it was announced like a day in advance. Well, what we'll do for this next time that we do this, I think we're going to know in advance when it's going to be. When I usually stream, it's just sporadic. I never know when I'm going to be streaming in advance. It's just like, oh, I'm going to stream just now. But for this next one of these, obviously, that we're going to do, we will know in advance. So what I'll do is I'll put out a scheduled stream. So it will show up on your YouTube homepage even a couple of days in advance, so you know when it's going to be. So that's what we'll do when we next do this. I'll put out a scheduled stream for this, so you know when it's going to be. I think that will help. Saturday I'll be working on the build, but it'll give me some entertainment. Yes, it won't be this Saturday. Maybe next Saturday. We'll see. Sunday evening should be good for most people. Sunday evening, yeah, maybe Sundays would be better. But yeah, I was thinking about that as well. People going to sleep for their job. Is it possible to convert a 1212 to 220 inverter to an amp? That'd be a fun project for him to test. Technically, yes, it is. It should be possible. I don't see why not. Obviously, the inverter is just generating a 50 hertz signal essentially. The only thing is that the way that those inverters work is it never generates a sine wave. They're weird. Even the true sine wave inverters, there isn't a perfect sine wave on like the output. It works in a weird way. I've done a video fixing an inverter, and that should show you how it works. But essentially, the chip that generates the signals for that to run on, it doesn't generate a sine wave, and it doesn't generate like pulses that are similar to what you'd get from a Class D. It's a bit strange, but it would be a fun project perhaps. I think you'd end up building an amplifier that did like 2000 watts into like 20 ohms or something like that. It'd be a bit useless, but it'd be nice if you had a Facebook group. Yeah, I do have a Facebook page. I've got a Bearvidge Facebook page, but I don't post on there when I'm going live, but maybe I could.
To be fair, I should have announced it as well, to be honest. That's my bad on my part.
Yeah, no, that's cool. But yeah, interesting stream. Unfortunately, it's sad that it wasn't more interesting. Have you got anything interesting to show the guys? Have you got any interesting bench tests that you can do that you haven't done yet, or that you want to do, or anything like that?
I mean,
we're losing viewers fast, so I think it's
yeah, as I say,
I think it's
I
fizzling
think
out.
leave for today. But what we could do is next time we can do the power wrist bench test in real time.
Power wrist bench test. What's that one?
Power wrist 10K, because I've not done it.
Oh, okay. Okay, yeah, cool.
So we can do that.
Yeah,
I'll get this
sounds
shit
good.
back up to you ASAP. But yeah, no, it's been brilliant. I'm just happy I didn't have to sleep with the smell of burnt amp, which is really nice.
Yeah, for sure. Well, guys, thanks so much for jumping on. I hope this was
Take care,
entertaining.
everyone.
And I'm glad that you like this format of live stream. We're going to do this again when the amp has been modified with some brand new parts. So look out for that. It's coming your way in the next couple of weeks. I will post up on my page as a scheduled stream when we're doing this. So thanks once again, guys. Massive thanks out to everyone who donated, especially Adrian for the 49,
thank you guys, man.
For the parts. That's wicked. Get those ordered, and yeah, spot on. We'll catch you in the next stream.
Take care.